Welcome to an Introduction to Economics, brought to you by Parkbench Tutors and narrated by David Hopcroft. For more information about Parkbench Tutors, please visit parkbenchtutors.com. This short podcast introduces simple ideas about firms and is the first in a series about firms. We shall focus our attention on the output of firms and the pricing, looking at the objectives that are set by firms, the types of firms, and the structure of industry. We shall begin by considering a firm operating in perfect competition, where it has the objective to maximize profit. Perfect competition means that there are no external factors that will influence the market, and that the marginal conditions for Pareto efficiency are satisfied. Some of you will have studied accounting, and it is important to bring out a difference between the way accountants and economists differ in how they consider opportunity costs. To an accountant, the cost of using a resource, such as plant and equipment, is a cost that is expensed over the lifetime of the equipment. The economist may consider there is no relationship here if the equipment has no other purpose and no scrap value. Opportunity costs are considered differently by economists. Here is an accountant's view of a market trader's performance over a year. Sales of $60,000 are made. The cost of sales is taken to be $40,000, giving a gross profit of $20,000. Expenses are then subtracted from gross profit to give net profit. Subtracting $10,000 of expenses gives a net profit of $10,000. For the economist, the opportunity cost is about considering the use of labor and capital. If there is $12,000 invested in the business, then the alternative use of this resource should be considered. Revenue could have been obtained from this in the form of interest. At 6%, this would have yielded a return of $720. The trader might also have earned $15,000 from employment if not operating as a market trader. So there is a total opportunity cost here of $15,720. Taking this view, we have a net loss of $5,720 because we need to subtract the opportunity cost from the net profit. This does not take into account what the market trader wishes to do, so it only places a monetary value of opportunity cost on the operation. We will now consider a firm operating with short-run costs. Remember that the short run in economics is the time period in which at least one factor of production can be varied and one factor cannot be altered. The factor which cannot be altered is called the fixed factor. The factor that may be altered is called the variable. As with accounting, we can break down costs into those costs that are fixed and those which are not fixed or variable. As simple examples, the cost of labor is dependent on outputs, since the greater the output, the more labor is needed. So labor would be an example of a variable cost. If machines are powered by electricity, then the electricity cost would be a variable. In contrast, if the factory were rented and the rent fixed per month, then the use of the space becomes a fixed cost. Total costs are made up of the total of fixed costs plus the total of variable costs. Our hypothetical firm is going to have one variable cost, which is going to be the labor cost. Remember that early on we introduced the idea that increasing labor will at first increase the output, but eventually we encountered the law of diminishing returns. In a perfectly competitive market, prices for other resources will be constant. The average variable cost will be given by dividing the total variable cost by the quantity produced. If we now plot the costs against output for average variable cost, then we obtain a shallow U-shaped curve. Our fixed cost, rent, cost of setting up equipment, and so forth, will be reduced if we produce more. To obtain the average fixed costs, we divide the total fixed costs by the quantity produced. When plotted as a graph, we have a curve that will slope downwards to the right. The more we produce, the lower the average fixed cost. In order to establish total costs, we simply sum the fixed and variable costs. So the average total costs are equal to average fixed costs plus average variable costs. This can also be written in another way. The average total cost will be the total cost divided by the quantity. So the graph of average total cost will be the sum of the first two. The shape of this shows that average total costs will fall sharply as fixed and variable costs are reduced. However, the variable costs will start to rise, and this will eventually cause the average total cost to rise at higher outputs. Now let us move on to marginal costs. Remember that the marginal cost is the change in the total cost that results from changing the level of output by 1 unit. We can write this as MC equals delta TC divided by delta Q. The graph that is plotted shows a U-shaped curve. Initially, marginal costs will fall to reach a low point. Then the marginal costs will start to increase. It has a similar shape to average total costs here. We can now relate marginal product to the labour employed. The marginal product of labour is the change in total product that results from the employment of each additional worker. So MP for marginal product is equal to delta TP for the total product divided by delta L for labour. You will recall from earlier podcasts that the marginal cost will reach a minimum when the marginal product reaches a maximum. After that point, the law of diminishing returns takes effect. So let us put all these graphs together, relating costs to output. You can see straight away the marginal cost line is the one we are going to be interested in since it cuts the other lines. The marginal cost line will intersect the average variable cost and the average total cost lines at their minimum points. Now let us turn to long-run costs. Remember that for a long run all the factors of production can be varied. A firm that wants to maximize profits will want to minimize costs of production. The long-run average cost curve is shown, but a cost-minimizing firm will only produce at points along its expansion path. The curve shows us the minimum average cost of production for each level of output. The minimum average cost of producing quantity OQ1 will be OC1, and so on. As the curve falls towards the lowest point, the firm is experiencing economies of scale. As it starts to rise, it will experience diseconomies of scale. I will say more about these in a moment. If a plant alters and varies output, it will then move along a short-run average cost curve. Each short-run curve meets the long-run curve at its tangent. The long-run curve is therefore an envelope curve. Now let us consider economies of scale. Economies of scale bring about a reduction in average cost as production rises. They can be achieved as a result of one or more of 4 factors: technical, financial, marketing, and risk-bearing. If the same action is performed repeatedly, and if a machine is designed for the purpose, then output increases. Think Henry Ford and production lines here. If a resource is needed at a particular temperature, then doubling the dimensions of the container increases capacity by 8 times, but surface area by only 4 times, so there will be less heat loss per unit. For high volume activity, an assembly line produces more output than trying to assemble the whole item at once. Automotive manufacturers recognized this a long time ago. Where a number of different machines are used in production, then a large manufacturer can have more of the machines that are needed most. The cost for all firms is research and development. The larger firms can afford to invest more and support their own research. Large firms will also find it easier to obtain finance, and the fixed costs of obtaining a loan will act to their advantage. Investors may also feel more secure in placing money with a large firm. An advertisement of, say, a half page is going to be a fixed price, but this cost will be less important for a firm with economies of scale because it will represent a smaller proportion of expenses. Small firms may be limited in their output to a small range of goods, whilst larger firms are able to diversify. We met this idea of diversification when we considered how tobacco firms had started to diversify. Firms need to hold an inventory to meet orders at short notice. It will be easier for a large firm to hold inventory. However, there are also disadvantages of scale. The larger a firm becomes, the more difficult it becomes to manage. A small firm can take and implement a decision to change very quickly. A large firm may have a series of processes to go through at different levels, which mean that even small decisions can take time. There is also some evidence to suggest that larger firms suffer more from labour disputes. When a number of firms congregate in the same area, then they experience locality advantage. This is evident in almost any large city in the United States, where most of the automotive dealers are likely to be found in a small area, often along the same street. The pottery industry in the United Kingdom was once centred around Stoke-on-Trent, the automotive industry around Detroit in the United States, and many high-tech factories were located in Silicon Valley. A supplier of components to the automotive industry is more likely to move into such an area and will benefit from economies of scale. The automotive manufacturer will benefit from lower costs for components. We started by saying that the aim of the firm was to maximize profit. Profit is the difference between the total revenues and the total costs. The total revenue can be determined by multiplying the price of a good by the quantity sold. The point at which profit is maximized depends on knowledge of marginal revenue and marginal costs. Marginal revenue is the change in total revenue by altering the level of output of one unit. Marginal cost is the change in total cost resulting from changing the level of output by one unit. Marginal revenue curves are derived from demand curves, so we will assume for the moment that the marginal revenue curve is going to fall and slope to the right. We have already considered the marginal cost curve. At point Q3 as an output, the marginal costs exceed marginal revenue, so the firm is making a loss. So what about Q1? The point to note here is that if the firm produced an additional unit, then since revenues are above cost, so the profit will increase. The desirable point is E. Producing one unit less would decrease profit, and producing one unit more will decrease profit. The maximum profit is therefore the point at which marginal costs and marginal revenue are equal. Suppose we have a situation where the marginal cost cuts the marginal revenue twice. In this case, we have shown a situation where marginal revenue remains the same regardless of the quantity sold. Moving from Q1 to Q3, the firm would increase profit, since marginal revenue would exceed marginal cost. Thus, Q1 cannot be the profit maximizing level. Above Q2, however, the costs exceed revenue. Q2 then is the intersect we seek. We now revise our rule slightly. To maximize profits, a firm should produce the quantity at which MR equals MC, provided that the MC curve is rising so that it cuts the MR curve from below this point. This ends our first podcast on firms, brought to you by Parkbench Tutors and narrated by David Hopcroft. Thank you for watching and for listening. We wish you success in your studies. For more information about Parkbench Tutors, please contact parkbenchtutors.com.